Now we're going to combine a few of the skills that we've learned, including finding the coordinates at a point, finding the gradient at a point, and bring these together to find the equation of a tangent to a curve. So let's imagine we have something very simple. I'll make it y equals x squared. So I'll try and draw y equals x squared as reasonably well as I can. So here is y equals x squared. Not well drawn, by the way. Not well drawn. And let's imagine we're going to find, let's say we've got a point, let's say that's 1 along, 1 up. Let's say this is 2 along, this is going to be, let's say 4 up. Here we go. So this would be, that's point 1, this is point 2, this is 2 along, comma, 4 up. So this is how the equation will play out. And 3 along, of course, would be 9 up. So this is the equation y equals x squared, and we're going to find the tangent to the curve at the point 2, comma 4. So I'll try and draw this. It's going to look something like this, yeah? I haven't drawn that particularly well, but you get the idea. There's a line, in other words, that just touches the curve, seems to touch all the other places as well, which is a bit of a nuisance, so it's not very easy to see that, but it's crossing at 2, comma 4. So we want to find the equation of this line that we've just drawn. And the line actually is sloping around a bit. It should probably actually go down more like that. But anyway, you'll get the idea. So let's find the equation of that line. Well, fortunately, really easy to do. So the first thing we want to do is we've got a coordinate. We've got an x value and a y value. Now we just need a gradient. If we knew the gradient and we knew those 2 points, we could either use the gradient intercept method, or y equals mx plus c, because we've got a y value and an x value. We just need the m value, and then of course we can find c and we're done. Or we could use the point gradient equation. We could say y minus y1 is equal to m, that's an m by the way, x minus x1, and that would do the same thing. That would give us the equation of the line. And all we need, again, is a y value, which we've got. There's our y value, it's 4. An x value, the x1 value is 2. And we just need the gradient. So what's the gradient? Well, let's find it. Let's find the gradient at the value of x equals 2. So let's do that now. So I'm going to differentiate y with respect to x. So x squared becomes 2x. There's my differential. So now what we're going to do is we're going to take that value 2. We're going to put it straight into the x value there, and that's going to give us our m value. So I'm going to have 2x, and I'm going to put the x value in of 2. Here it goes. So m is going to equal 2 times, or 2 is x, so it's 2 times 2. So m is equal to 4. So now we've got everything we need to go ahead and draw the line. We've got an x value, a y value, and an m value. So we could do this in 2 different ways. One is use y equals mx plus c, or the gradient intercept. I'm going to use that method to start with. So I've got y is equal to mx plus c. I'm going to insert the values we know. So we do know we've got y. Well, y was 2, comma 4. So y is 4. M we decided was, where's m? Here's m, it's 4. So here's my m value, 4. The x value, what was x? X was 2. 4 times 2 plus c. All right, let's see how that plays out. So we've got 4 is equal to x times 2. So 4 is equal to 8 plus c. So we just need to find out the value of c. So I'm going to subtract 8 from both sides. There it goes. So 4 minus 8 is going to be negative 4. So c is equal to negative 4. Now we're complete. We're ready to restate the equation. So y is equal to m, which was 4x minus 4. And there is the equation of the tangent to the curve y equals x squared. And that's what we want to put. So what that is the equation of the tangent. Sorry, you can't see that. The tangent to the curve y equals x squared at, and I want to put the at thing because I want to say 2, comma 4. And that's what you need to put, yeah? So state the equation Also therefore, yeah? Therefore, y equals 4x minus 4 is the equation of the tangent to the curve y equals x squared at the point 2, comma 4. Put all of that and you're cooking with gas. Straight away, that's the answer. Or you could, of course, have used the point gradient equation. So to do that exactly the same way, I'll just do that just for a bit of fun. So here we got y minus y1 is equal to mx minus x1. So we're going to insert the same values, substitute the same values. So y minus y1. So y1 was 4 is equal to m, which was 4. X minus x1, well, x was 2. And of course, we should come up with exactly the same thing. So we've got y minus 4 is equal to, well, 4 times x is 4x. 4 times negative 2 is minus 8. Now, we just need to get rid of this minus 4 here. So I'm going to add 4 to both sides. So y is equal to 4x, and negative 8 plus 4 is negative 4. And there's the equation. Now notice you would need to state this here as well, that this, you've just found this, and that is the equation of the tangent to the curve y equals x squared when we're at the point 2, comma 4. And that's how we find the equation of a tangent to a curve.